Now in this chapter explaining very important questions, and students, this method whatever we perform in these questions, it will be useful in next coming chapters, differentiation, integration. So very important topic. These are questions of the type prove that. Say this is first question. Prove that 3 times sine inverse x equal to sine inverse 3x minus 4x cube. So here method is, if you observe this right hand side, then in the right hand side, if you observe this inner part, then you can find matching of this inner part with a trigonometric result. There is a formula in trigonometry: 3 sine theta minus 4 sine cube theta. So you can match this with 3 sine theta minus 4 sine cube theta. So we can fix here sine theta. So let us see what happens if we put there x equal to sine theta. So we take substitute. We are taking x equal to sine theta here. Taking x equal to sine theta, so left hand side will be, see, right hand side will be, this is right hand side. So right hand side will be sine inverse 3x minus 4x cube sine inverse, putting here x sine theta, so 3 sine theta minus 4 sine cube theta. So this becomes sine 3 theta. Now sine 3 theta equal to 3 theta is allowed if 3 theta belongs to domain of sine. We know these results, that sine inverse sine theta is theta if theta belongs to minus pi by 2 to pi by 2. So in place of theta, here it is 3 theta. So sine inverse sine 3 theta equal to 3 theta if 3 theta belongs to minus pi by 2 to pi by 2. If you read here alpha, then you have to put here alpha. So result is sine inverse sine alpha is alpha if alpha belongs to minus pi by 2 to pi by 2. And here value of alpha is 3 theta. So it will be 3 theta if 3 theta belongs to minus pi by 2 to pi by 2. So we have to check existence of 3 theta, that where does it lie. If it lies in closed interval minus pi by 2 to pi by 2, then and only then we can remove the sine inverse sine and value will be 3 theta. So how to check it? For that, say here we use this condition. We have taken x equal to sine theta. X equal to sine theta, now say here x is between minus half to plus half. X belongs to closed interval. So x is more than or equal to minus half, less than or equal to half. Now x is sine theta. So that is, here I am putting sine theta. So 1 by 2 replace as sine pi by 6 and minus 1 by 2 replace by sine of minus pi by 6. Try to take these values belonging to domain of sine. Minus pi by 6, it belongs to 4th quadrant. Plus pi by 6, it is in 1st quadrant. X is sine theta. So this side and this side take values in terms of sine. Now I am removing this function. So removing this function, here I keep these values. Now see, in this interval minus pi by 2 6 to pi by 6, minus pi by 6 is somewhere here, plus pi by 6 is somewhere here. In this interval, sine is increasing function. When theta changes values from minus pi by 6 to pi by 6, y coordinate on this circle, y coordinate of every point is going up. So sine is increasing, and when we remove increasing function, this sign of inequality remains unchanged. So theta is in minus pi by 6 to pi by 6. So that means theta is in domain of sine. Minus pi by 6 to pi by 6, it is subset of minus pi by 6 to pi by 6. This is subset of minus pi by 2 to pi by 2. So we have proved that theta in this interval, and this is a subset of this interval, that means theta belongs to minus pi by 2 to pi by 2. So this is in domain of sine. Therefore from this step, sine inverse x equal to theta. So from this step, sine inverse x equal to theta is allowed. Reason is here, because theta belongs to minus pi by 2 to pi by 2. So here this was allowed. Here no need to show this last step. It is understood because this is already contained in domain of sine that I have shown here. Now we are going here in further procedure. Now see, we were at here. We want to check where does 3 theta lies. So see, already here we have proved that theta is between minus pi by 6 to pi by 6. Already here proved. We want to check about 3 theta. So multiplying by 3, this will be in minus pi by 2 to pi by 2. So now you can see that 3 theta belongs to minus pi by 2 to pi by 2. It is domain of sine. 3 theta belongs to minus pi by 2 to pi by 2. Therefore sine inverse sine 3 theta equal to 3 theta. So now we are allowed to put this equal to 3 theta. So reason for this step is explained here. Now value of theta, say theta is, if we say this is equation 1, so value of theta is sine inverse x. This is from 1 and it is LHS. This is LHS. So LHS is equal to RHS. Now let us discuss similar next question. In this question, prove that 3 times cos inverse x equal to cos inverse 4x cube minus 3x. Look RHS. Here you can find matching with 4 cos cube theta minus 3 cos theta. In this method, in every problem, outer will be inverse function, and whatever is inner part, the pattern of inner part, it will be matched with trigonometric formulas. So here this is matched with 4 cos cube theta minus 3 cos theta. So in this question, similarly, we are taking substitute. x equal to cos theta. X is cos theta. Now see, here x is between 1 by 2 and 1. This is given. Always we use this condition. Now x is cos theta, so I keep here cos theta. Because this is cosine, here also we keep in terms of cosine, here in terms of cosine. 1 is cos of 0 and 1 by 2 is cos of pi by 3. See, here we are going to use this result. Cos inverse cos alpha is alpha. If alpha belongs to domain of cosine, this is domain of cosine, so try to take these values on left and right side, both belonging to this interval, and here they are. Now I am removing cosine. Removing cosine values I have kept as they are. But see what happens here, we cannot continue inequality in the same direction. This is wrong, because pi by 3 is not less than 0. So here what is happening, here see, this number is pi by 3, so pi by 3 is somewhere here. This number is 0, 0 is here. Pi by 3, 0, both numbers put on unit circle. See, this is unit circle. Now when theta moves from 0 to pi by 3, theta is increasing. When theta is increasing, every point's x coordinate is decreasing. See, x coordinate is going back. So x is decreasing, that means cosine is decreasing. In first quadrant, cosine is decreasing, and when we remove cosine function, sign of inequality will be reversed. This sign is reversed because cos is decreasing function. So this means 0 less than or equal to theta less than or equal to pi by 3. So theta is in 0 to pi by 3, and 0 to pi by 3 is subset of 0 to pi. So theta belongs to domain of cosine. So after this step, we can put cos inverse x equal to theta. So reason for this step is explained here, and we say this is 1. And now using this value on the right hand side, RHS is cos inverse 4x cube minus 3x, cos inverse 4 cos cube theta minus 3 cos theta. This is cos 3 theta. Cos inverse cos 3 theta equal to 3 theta if 3 theta belongs to domain of cosine. If 3 theta belongs to domain of cosine 0 to pi, then we are allowed next step 3 theta. So let us check where does it lie. So for that, say we were at here, theta between 0 to pi by 3. Now multiplying by 3, we want to know about 3 theta. So multiply by 3. So 0 less than or equal to 3 theta less than or equal to pi. And now you can see that 3 theta belongs to closed interval 0 to pi. So this number belongs to domain of a cosine. So cos inverse cos 3 theta is 3 theta. So it is equal to, now using this value, theta is cos inverse x. So it is from 1. Therefore, this is left hand side. So LHS is equal to RHS. Result is true. Now write simple form of this expression. Say here, outer function is tan inverse, inner function is 1 upon root x square minus 1. Outer function is tan inverse. So in last question, when outer was sine inverse, we tried to get sine inside. When outer was cos inverse, we tried or we obtained cos inside. So outer is tan inverse. So here we want tan of something. Now to obtain inside tan of something, here we have to obtain 1 upon cot of something. To obtain this number, we have to obtain this number. So here numerator is 1. So value of denominator we want in terms of cot alpha. And to obtain here cot alpha, we have to take substitute x equal to cosec alpha. So cosec square minus 1 will be cot square, and square root of cot square can be obtained in terms of cot. So here in this question, we are taking x equal to cosec alpha. This is the way how to choose a substitute. Now before taking next step, see next step will be cosec inverse x equal to alpha. But when this is allowed? If alpha belongs to domain of cosec. And what is domain of a cosec? Restricted domain of cosec is closed interval minus pi by 2 to pi by 2 except 0. This is domain of cosec. So if we can show alpha belongs to domain of cosec, then x equal to cosec alpha implies cosec inverse, means this cosec can be shifted on this side. So let us check where does alpha lie. So we use this condition. So here modulus x is more than 1. Modulus x is more than 1, that means modulus of cosec alpha is more than 1. Modulus of cosec alpha is more than 1, that means, say here, equal to 1 is not given. Equal to 1 is not given. So cosec alpha is not equal to pi by 2. Cosec alpha will not be equal to, sorry, here sign of equality is not given, that means cosec alpha, its modulus is not equal to 1. So cosec alpha will be neither plus 1 nor minus 1. Cosec alpha will be neither plus 1 nor minus 1, that means alpha will not be equal to pi by 2 or minus pi by 2. So we are excluding those endpoints. So this means alpha belongs to open interval minus pi by 2 to pi by 2 except 0. Or this can also be expressed as by this way, that modulus x is more than 1. That means x is less than minus 1 or x is more than 1. X is less than minus 1, that means cosec alpha is less than minus 1, cosec alpha is more than 1. When cosec alpha is less than minus 1, then alpha will be from fourth quadrant. So alpha belongs to open interval minus pi by 2 to 0. So I have taken fourth quadrant from this interval. Or alpha belongs to, when this is positive, so alpha will be from first quadrant, and joining this 2, it is open minus pi by 2 to pi by 2 except 0. So I think this way is better. So I am putting by this way. Modulus x is more than 1. That means x is less than minus 1 or x is more than 1. That means cosec alpha is less than minus 1 or cosec alpha is more than 1. When cosec alpha is less than minus 1, alpha belongs to open minus pi by 2 to 0. Take subset of its domain. So from this domain, this subset represents fourth quadrant, or alpha belongs to 0 to pi by 2. See, everything we are writing by taking help of its domain. This is the domain. So take part of only domain. We are not taking here close interval minus pi by 2. We don't here close this interval to at pi by 2, because here sign of equality is not given. If you are given here sign of equality, then it will be equal, equal, this will be equal, equal, then we should include minus pi by 2 and plus pi by 2. But here we are excluding, because modulus x is not equal to 1. It is more than 1. So here you can see that this is subset of domain of cosec. So that's why this is allowed. Reason for this step, it is here. Now, using value in given expression, tan inverse 1 upon root x square minus 1. This is equal to tan inverse 1 upon root x means cosec alpha, cosec square alpha minus 1. So this will be tan inverse 1 upon root cot square alpha. This means tan inverse, see, root cot square alpha. Square root of cot square alpha is modulus cot alpha. During this whole method, during all the questions or in this mathematics, you always remember square root of x square equal to x is not a complete answer. Square root of x square is modulus x, because square root is always positive. Square root of sine square theta, we will keep modulus sine theta. Square root of tan square theta, we will keep modulus tan theta. So wherever we will have square root, here square root of cot square alpha is similarly modulus cot alpha. Without modulus we cannot keep value. Now we want to remove this modulus. Now see, there are two possibilities for alpha. If alpha is in this quadrant, then cot is negative. Let me keep one more step. Tan inverse, now here I keep modulus of tan alpha. Now after this step I am differing. Say, this is equal to, now removing modulus, tan inverse modulus tan alpha. Modulus tan alpha is tan alpha. If tan alpha is positive, but when tan alpha is positive, if alpha belongs to 0 to pi by 2, if alpha belongs to this interval, then tan alpha is positive, so modulus tan alpha is tan alpha. Modulus tan alpha is minus tan alpha. Modulus x is minus x. When modulus x is minus x, if x is negative. So when modulus tan alpha is minus tan alpha, if tan alpha is negative. And where tan alpha is negative? It is negative in fourth quadrant. So if alpha belongs to minus pi by 2 to 0. So in every question we will work according to given condition. In every question, if such restriction is given, then our discussion should be in that restriction. Now here tan inverse tan alpha minus I am taking outside tan inverse tan alpha. That is, if alpha belongs to 0 to pi by 2, here alpha belongs to minus pi by 2 to 0. Tan inverse minus x is minus tan inverse x. Now see, tan inverse tan alpha equal to alpha, because alpha is in domain of a tan. Say this is subset of a domain of tan. If alpha is in minus pi by 2 to pi by 2, then tan inverse tan alpha is alpha. And here it is. Alpha is in this set, so it is already in this set. Similarly here, alpha is in this set, therefore it is in this set. So tan inverse tan alpha minus as it is, and tan inverse tan alpha is alpha. So condition is alpha belongs to 0 to pi by 2, alpha belongs to minus pi by 2 to 0. Now coming back in terms of x, putting value of alpha, alpha is cosec inverse x. So here cosec inverse x, here minus cosec inverse x. Now we come back in x. So now this condition should be converted into x. So here when alpha is in 0 to pi by 2, alpha is in 0 to pi by 2. At that time x is more than 1. So here I keep condition x more than 1. And when alpha is in minus pi by 2 to 0, at that time x is less than minus 1. So x is less than minus 1. Now we can show this as final answer in this question. Simple form. This simple form can also be converted in terms of a sec inverse. See, we have a property. We know that sec inverse x plus cosec inverse x is pi by 2 if modulus x is more than 1. If modulus x is more than or equal to 1, we know this is the property. So cosec inverse x, it can be replaced by pi by 2 minus sec inverse x. So here cosec inverse x I replace by pi by 2 minus sec inverse x if x is more than 1. Similarly here pi by 2 minus sec inverse x if x is less than minus 1. So reason for this step, it is here. I should write this in lower exactly inside of this step. Reason, because sec inverse x plus cosec inverse x is pi by 2 when modulus x is more than 1. So this is used here. So this is equal to pi by 2 minus sec inverse x if x is more than 1 and it is minus pi by 2 plus sec inverse x if x is less than minus 1. Thus, simple form of given expression equal to pi by 2 minus sec inverse x if x is more than 1 minus pi by 2 plus sec inverse x if x is less than minus 1. Simplify this expression. Condition is given. X lies between minus pi by 4 to 3 pi by 4. Say here tan inverse cos x minus sin x upon cos x plus sin x is given. So beginning from this given expression, say in this method always we try to obtain similar function as it is in outside. Means outside if there is tan, then inside we try to get tan inverse. If outside there is a sec, we try to get sec inverse. If outside is cos, inside try to get cos inverse. So similar. So here outside is tan inverse. So inside we want tan inverse, tan function. So for which here what we do, numerator and denominator, I am dividing by cos x. Divide this by cos x, so it is 1. Divide by cos x, so it is tan x. Divide by cos x, 1. Divide by sin x, tan x. So dividing inside numerator and denominator by cos x. So now this is then, see this 1 you can see as tan pi by 4. This one keep as it is. Here imagine coefficient of tan x 1, and it is coefficient of tan x is 1. So that 1 replaced by tan pi by 4. Tan x as it is. So doing this we have pattern of tan alpha minus tan beta upon 1 plus tan alpha tan beta. So this is equal to tan inverse tan of alpha minus beta. Tan alpha minus tan beta upon 1 plus tan alpha tan beta is tan of alpha minus beta. And now you can see that outer is tan inverse, inner is tan. This can be removed if this number belongs to domain of tan. That means if this number is in domain of tan, restricted domain of tan, then we can remove tan inverse tan and value will be pi by 4 minus x. If this number does not belong to this interval, then its value will not be equal to pi by 4 minus x. So let us check where does it lie, for which we use condition. Say here condition is x is between minus pi by 4 and 3 pi by 4. Now we create this number. Now x is with a negative sign. So multiplying this by minus 1, multiplying by minus 1, inequality will be changed. Whenever any inequality we multiply by negative number, sign of inequality will be changed. Now rewriting this again from smaller to greater. This is smaller, then x is smaller, then pi by 4. Smaller to greater. Now this is derived, minus x is created. Now we want to add pi by 4. Here we want pi by 4. So adding pi by 4 adding on left side, pi by 4 adding in middle, pi by 4 adding on right side. So this is pi minus 3 minus 2 pi by 4, it is minus pi by 2, and this is pi by 2. And say pi by 4 minus x belongs to minus pi by 2 to pi by 2. It belongs to domain of tan. We have proved that this number is in domain of tan, so tan inverse tan can be removed. So this is, it's a simple form. So this is required simple form. Therefore, required simple form is pi by 4 minus x. Now, similarly, we take in this question, simplifying this expression, here tan inverse square root of 1 minus cos x upon 1 plus cos x. Already a trigonometric result is given. 1 minus cos x upon 1 plus cos x, it is tan square x by 2. There is a trigonometric formula, 1 minus cos x upon 1 plus cos x, tan square x by 2. Now, square root of tan square x by 2, it is modulus tan x by 2. Square root of t square is modulus t, not only t. So, square root of t square is modulus t. Now, we want to remove this modulus. If this number is positive, then mod t is t. If the number is negative, mod t is minus t. So let us check what is sine of tan x by 2. So say here x is in 0 to pi. So dividing this by 2, x by 2 is between 0 and pi by 2. So x by 2 is in first quadrant. X by 2 is in first quadrant, therefore tan x by 2 is positive. So modulus tan x by 2 equal to tan x by 2. So this is equal to tan x by 2. Reason for this step is here. And now tan inverse tan x by 2 equal to x by 2. If this number belongs to domain of a tan, and it is already in domain of tan, here it is shown. So because x by 2 belongs to 0 to pi by 2, 0 to pi by 2 is subset of minus pi by 2 to pi by 2. So therefore x by 2 is in this set. So allow to remove tan inverse tan. So therefore tan inverse square root of 1 minus cos x upon 1 plus cos x, it is equal to x by 2 under this condition. If x is in this interval, then this is its simple form. Simplify this expression. See, observe inner part. In inner part, there is in denominator a square minus x square is given. If you are given radical sign, focus on radical sign. And whenever such a radical sign is given, taking trigonometric substitution, we can remove this radical sign. See here a square minus x square is given. So we can find matching with 1 minus sine square theta. If we can create square root of 1 minus sine square theta, then it will be square root of cos square theta. and square root can be removed. So to set here 1 minus sine square theta, because we need here 1, so what we shall do here, we have to put, or we have to take x equal to a sine theta. So if you take x equal to a sine theta, then a square can be taken out. So then that will be 1 minus sine square theta. So after taking a square common, we can get 1 minus sine square and its square root and its value cos square. So we take substitute here x equal to a sine theta. So we are taking x equal to a sine theta. X equal to a sine theta, it means x by a equal to sine theta. That means x by a is sine theta. X by a is sine theta. From this expression, sine inverse x by a equal to theta is allowed if theta belongs to domain of sine. So before writing this step, let us check where does theta lie. So we come on this condition. Say here modulus x is less than a. Modulus x is less than a, that means x lies between minus a and a. Dividing by a, minus 1 less than x by a less than 1 divided by a. Now x by a is taken here sine theta. So sine theta 1 minus 1. X by a is sine theta, so 1 we replace by sine pi by 2 and minus 1 we replace by sine of minus pi by 2. Now on interval minus pi by 2 to pi by 2, sine is increasing. So removing this sine function, inequality remains unchanged, and you can see that theta belongs to domain of sine. This is domain of sine. Therefore, this sine can be shifted on this side. So sine inverse x by a is theta, and reason for this step is here. Everything we put by reason using properties of inverse trigonometric function. So this value will be used later on. Now given expression tan inverse x upon root a square minus x square, we are putting values in this equal to tan inverse x is a sine theta. Here we have taken x equal to a sine theta upon square root of a square minus x is a sine theta, so its square is a square sine square theta. That is tan inverse a sine theta upon, say, root a square, square root of a square, that is taking a square common, a square minus a square sine theta, so it is 1 minus sine square theta. Now see, a is positive. Here a is positive. How we can say a positive? Because this is modulus. Modulus is always positive. Any positive number less than a, it is true if a is positive. Modulus x is itself a positive, and this positive is less than a. It is true if a is positive. Whenever on number line, if you take 5 and if 5 is less than something, here 5 is less than something, suppose something is a, So that means this number is on the right hand side of positive. So obviously it will be positive. This number is on right hand side of positive. So obviously a is positive, and square root of a square, because a is positive, square root of a square is a. And here this is cos square theta. A is obviously positive. We can't say cos theta is positive. Cos theta can also be negative. So here root cos square theta, we keep modulus cos theta. Root cos square theta is modulus cos theta. Now see, theta is in minus pi by 2 to pi by 2. So it covers fourth and first quadrant. In fourth and first quadrant, cos is positive. So in the next step, it is equal to, after this step we are continuing here, tan inverse a sin theta upon a cos theta, because theta is in minus pi by 2 to pi by 2, because theta is in minus pi by 2 to pi by 2, so cos theta is positive. This is the reason for this step. Theta is in fourth and first quadrant, so cos is positive, so modulus cos theta is cos theta. Now this is cancelled, so tan inverse tan theta. Now look, theta, already it is in domain of tan, so tan inverse tan theta is theta, because theta belongs to minus pi by 2 to pi by 2, already proved here. And what is value of theta? Theta is sine inverse x by a. This is from 1. So simple form is, therefore tan inverse x upon root a square minus x square, it is equal to sine inverse x upon a if modulus x is less than a. So in these methods, domain of restricted domain of all 6 functions, very important. Now see here, given expression tan inverse 3a square x minus x cube upon a cube minus 3ax square. Now look this pattern, observe inner pattern. You can see that this is something like 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. This is hidden in this expression. Now to bring out this pattern, from this pattern, this is hidden and we want to bring out. So what we shall do? Here we need 1. So here we need 1. So what I do? I am dividing by a cube. Dividing by a cube, this number divided by a cube, so it will be x by a, minus divide by a cube, so it will be x by a cube, divide by a cube, divide by a cube, so 3 into x by a whole square. So what is done? Dividing by a cube, divided inside. So now say here, you can see that here Now new pattern, the design of inner part you can match with, say 3 tan theta minus 10 cube theta upon 1 minus 3 tan square theta. So x by a, we can take x by a equal to tan theta. So in this expression we are taking x by a equal to tan theta. This is the way how to take substitute. So always try to find a hidden part, hidden expression of trigonometric formula in every such trigonometric function. X by a is tan theta. Now say we want tan inverse x by a equal to theta, but if this theta is in domain of tan, then this is allowed. So let us check inside. Here we are checking. See, x is between minus a by root 3, a by root 3. This is given. A is positive. Now we want to know about x by a. So dividing by a is positive. So sign of inequality remains unchanged. Divided by a. Now x by a, I am putting here tan theta. So here this is tan theta, so I am putting here tan pi by 6 and here tan of minus pi by 6. Minus 1 by root 3 tan of minus pi by 6. We select these numbers so that both numbers belong to domain of tan. Domain of tan is open interval minus pi by 2 to pi by 2. So accordingly we have selected. Now tan is increasing function. Moving theta from minus pi by 6 to pi by 6, tan is increasing and defined. So removing this tan, sign of inequality remains unchanged, and you can see that now theta, it is already in a restricted domain of tan. Therefore this can be shifted on this side in terms of tan inverse. So reason for this step is shown here. We say this is 1. So now let me say this is 2. This is 1 and this is 2. So now using this value in 2, so therefore from equation 2, given expression equal to, this is given expression equal to tan inverse 3 into, this is tan theta minus tan cube theta upon 1 minus 3 tan square theta. So this is now tan 3 theta. So it is equal to tan inverse tan 3 theta. Now let us check about 3 theta. So say here we were at here, theta is between minus pi by 6 and pi by 6. Now multiplying this by 3, so it is between minus pi by 2 and pi by 2. This is multiplied by 3. So 3 theta, it is in domain of a tan. So this can be removed. It is 3 theta. Reason for this step is here. And value of theta is tan inverse x by a. This is required form. Therefore tan inverse 3a square x minus x cube upon a cube minus 3ax square equal to 3 times tan inverse x by a, where a is positive and x lies between. Under this condition, this is derived. So this is required simple form. Prove that tan inverse root x is equal to 1 by 2 times cos inverse 1 minus x upon 1 plus x. X belongs to 0 to 1. Say this question proving slightly in a different way. Beginning from left hand side is tan inverse root x. Now this LHS I divide and multiply by 2. Divided and multiplied by 2. Because here we want to use a result. See, result was, we know that 2 times tan inverse y is equal to cos inverse 1 minus y square upon 1 plus y square, where y is greater than 0. Already we are having this result. 2 times tan inverse x is cos inverse 1 minus x square upon 1 plus x square if x is positive. Now look here, root x. See, x is in 0 to 1. So x is positive. That means root x is positive. So here root x can be replaced. So 2 times tan inverse root x is equal to cos inverse 1 minus root x square upon 1 plus root x square. So application of this formula, because root x is positive, therefore 1 by 2 times cos inverse 1 minus x upon 1 plus x is proved. This is equal to RHS. So LHS is equal to RHS. In this question, beginning from left hand side, 9 pi by 8 minus 9 by 4 sine inverse 1 by 3. Say 9 by 4 is common. 9 by 4 common, so what is left? Pi by 2 minus sine inverse 1 by 3. Now we know that sine inverse x plus cos inverse x is equal to pi by 2. So pi by 2 minus, therefore pi by 2 minus sine inverse x is cos inverse x. So using this result, pi by 2 minus sine inverse x is cos inverse x. This result is proved. Now we want the right hand side in terms of sine inverse. So what we do now, here to convert this into sine inverse, we do parallel calculation. Suppose that cos inverse 1 by 3 is x. Cos inverse 1 by 3 is x. So cos x is 1 by 3. Cos x is 1 by 3. So sin x is square root of 1 minus 1 by 9. So sin x is square root of 8 by 9. So sin x is 2 root 2 by 3. And sin x is 2 root 2 by 3. So x is sin inverse 2 root 2 by 3. So what is proved? That means cos inverse 1 by 3, it was x. Cos inverse 1 by 3 equal to x, and x is sin inverse 2 root 2 by 3. So therefore value of cos inverse 1 by 3 is sine inverse 2 root 2 by 3. Reason for this step is here. This is the reason. So this is the way to prove this type of questions. So to prove this question, beginning from left hand side is cot inverse square root of 1 plus sine x plus square root of 1 minus sine x upon square root of 1 plus sine x minus square root of 1 minus sine x. This is left hand side. Here inside this function, this number, we multiply and divide by its conjugate. Means we multiply and divide by conjugate of a denominator. See what we do? We multiply and divide by conjugate of denominator. This is minus sign, so put here plus sign. Here minus is given, keep here plus. Root 1 minus sine x. Same we keep in numerator. So root 1 plus sine x plus root 1 minus sine x. So numerator and denominator multiplied and divided by this number. So therefore cot inverse of, say this is same number, numerator there is same, so it is root 1 plus sine x plus root 1 minus sine x whole square, and in denominator root a minus root b, root a plus root b, that is a square minus b square. So radical sign is removed from denominator. That is cot inverse. Now expanding numerator, a plus b whole square, so it is a square plus 2 into a into b, so a into b will be root a into root b, root ab, so 1 minus sine square x. 1 plus sine x into 1 minus sine x is 1 minus sine square x, plus this will be 1 minus sine x upon this 1 plus sine x minus 1 plus sine x. So here 1 this will be cancelled. In numerator this sine x will be cancelled. So this is cot inverse 1 plus 1 2 plus 2 into square root of 1 minus sine square x is cos square x upon 2 sine x. Now here 2 will be cancelled, so it is equal to cot inverse 1 plus, now see root cos square x is modulus cos x. Root cos square x is modulus cos x, because cos x can be positive, it can be negative. But in question it is given that x belongs to 0 to pi by 4. So this is subset of first quadrant, so cos x is positive, so modulus cos x will be equal to cos x. So I keep here cos x. This is the reason why modulus cos x is cos x, because cos x is positive. So this will be equal to cot inverse of, now 1 plus cos x is 2 cos square x by 2. So sin x also we keep in terms of x by 2, so it is 2 sin x by 2 into cos x by 2. This 2 is cancelled, a cos x by 2 will be cancelled, so what is left? It is cos x by 2 upon sin x by 2 is left. So this is cot x by 2 is left. Now cot inverse cot x by 2 is x by 2 if x by 2 belongs to domain of cot. So let us check inside. So here x belongs to 0 to pi by 4. It is given. So x by 2 belongs to 0 to pi by 8. And already this is subset of domain of cot. Domain of cot is 0 to pi. So therefore this is in domain of cot. Cot inverse cot alpha is alpha. Reason for this step is here. So this is its required value. Sorry, here there is a printing mistake in the textbook. This is x by 2. So RHS is obtained. Therefore LHS equal to RHS. Result is derived. Say to prove this question, observe left hand side. In left hand side, observe this inner part. In inner part, radical sign, inside the radical sign there are two type of expressions, root 1 plus x and root 1 minus x. And observing this inner part, these numbers, you can see that we are having matching of these expressions. 1 plus cos theta, if we keep here x equal to cos theta, it gives 2 cos square theta by 2. This will be 2 sin square theta by 2 and square root of cos square. So then it can be removed using modulus. So it works. So we take in this question, take x equal to, substitute cos theta, x equal to cos theta. Now cos inverse x equal to theta is allowed if theta belongs to domain of cos. So let us check inside. Say here we are given that x is between minus 1 by root 2 and 1. So x means cos theta. So on both sides, left hand side, right hand side, we terms values in terms of cosine. 1 is cos 0 minus 1 by root 2. See, this is negative. So take from second quadrant. So it will be 3 pi by 4, because whenever we discuss the problem of cosine, domain of cosine is 0 to pi. So that's why taken from second quadrant, 3 pi by 4. Now when theta moves from 0 to 3 pi by 4, here cosine is decreasing. So removing decreasing function, sign of inequality will be reversed. Inequality is reversed because cosine decreasing. So that means theta between 0 and 3 pi by 4. Arranging from smaller to greater. And now you can see theta is in domain of cosine. So therefore cos inverse x equal to theta. Reason for this step is shown inside, and we say this is 1. So therefore putting values in left hand side, LHS is, we copy LHS as it is. This is LHS. Now I put x equal to cos theta. So x is cos theta. Here 1 minus cos theta. Again x is 1 plus cos theta. X is cos theta. So next step is 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Again 2 cos square theta by 2. 2 sin square theta by 2. So therefore it is equal to tan inverse, say square root of 2, it will be cancelled. So what is left? Root cos square theta by 2. Root cos square theta by 2 is modulus cos theta by 2. Root sin square theta by 2 is modulus sin theta by 2. Similarly in denominator, modulus cos theta by 2, modulus sin theta by 2. Now to remove this modulus sign, we have to check whether cos theta by 2 is positive or negative, sin theta by 2 is positive or negative. For which we have to check that theta by 2, it lies in which quadrant. So see, here we were at here. See, theta is in 0 to 3 pi by 4. So theta by 2 will be between 0 to 3 pi by 8. This number is less than pi by 2. If it is 4 pi by 8, see, this is less than 4 pi by 8. 4 pi by 8 means pi by 2. So obviously this number is less than pi by 2. So here this interval is part of a first quadrant. So therefore cos theta by 2 and sin theta by 2 both are positive. Therefore modulus of cos theta by 2 is cos theta by 2 and modulus of sin theta by 2 is sin theta by 2. So using these values, tan inverse cos theta by 2 minus sin theta by 2 upon cos theta by 2 minus sin theta by 2. This is the reason for this step. Now here outer is tan inverse and inner we can set tan. As we have done in one question, we divide this numerator and denominator by cosine. So divide this by cos theta by 2, so it will be 1 minus tan theta by 2 upon, divide this by cos, 1 minus, say here this is plus, sorry I have done here mistake, this is plus, so 1 plus tan theta by 2. Numerator and denominator divided by cos theta by 2. So this is then tan inverse, 1 is tan theta, 1 is tan pi by 4 minus tan theta by 2 upon 1 plus this one you consider as tan pi by 4 into tan theta by 2. So this is tan inverse tan of pi by 4 minus theta by 2. Now does this number belong to domain of tan? If yes, then we can remove tan inverse tan, otherwise not. So let us check where does it belong. Say here theta by 2, we were at here, theta by 2 between 0 and 3 pi by 8. To create this number, now I multiply by minus sign, means multiplying by minus 1. So multiplying by minus 1, here inequality will be changed, 0 more than minus 3 pi by 8. But arranging from smaller to greater, minus 3 pi by 8 comes here, then smaller 0. Now adding pi by 4, pi by 4 minus 3 pi by 8, pi by 4 minus 3 pi by 2, pi by 4. Now this difference is, this is 2 pi by 8 minus 3 pi by 8. So minus pi by 8, pi by 4 minus theta by 2, pi by 4. And say this number, let me say call it alpha. So alpha is, where is alpha? Alpha belongs to minus pi by 8 to pi by 4. Alpha lies in this interval, and this is subset of minus pi by 2 to pi by 2. So that means pi by 4 minus theta by 2 belongs to minus pi by 2 to pi by 2, which is domain of tan. So tan inverse tan can be removed, so it is equal to pi by 4 minus theta by 2. This is the reason to remove this tan inverse tan. Everything we are doing by reason. It is not like that anytime you remove tan inverse tan. Anytime we do not cut tan inverse tan or sin inverse sin or cos inverse cos. Now putting value of theta. Theta is cos inverse x. So this is RHS. It is equal to RHS. So LHS equal to RHS. Result is proved.